So we got this beautiful concept, radical axis and radical center. So first try to understand what is radical axis. Okay, so try to understand this part. So radical axis means it's a straight line first. Okay, from where you can drop tangents of equal length. Okay, I'll write down the definition. The radical axis of two circles, okay, is the locus of points, means collection of points, which moves in a plane in such a way that the line in such a way that that the length of tangent, okay, drawn from it, okay, to the two circles, okay, are same. Okay, now try to understand. Suppose that this is the first circle and this is second circle, okay, and you have to drop down, like suppose it's a line, randomly I am writing. Okay, so suppose that from this line, like suppose this is the point, you drop down first tangent, you drop down one tangent on this circle, okay, and if these two things comes out to be same, okay, and slowly you guys are taking so many points on this line and the length of tangent comes out to be same, then you can say that this is a radical axis. Who is this one? Radical axis. Radical axis. Okay, so how we will get equation of radical axis? Try to understand. So don't you think that we have covered what? Sir, we have compared length of tangent. Acha, how we used to find length of tangent, do you remember? Root of S1, correct? We used to satisfy the point. No, suppose that this is point P, H comma K. So I'll satisfy H comma K in this curve. So root S1 we will get. I will satisfy the point P, H comma K in S2. Okay, and you know that you are substituting H comma K. It's not the number, it is H comma K, which you will later replace with X and Y. So don't you think you will just write equation of circle 1 is equal to equation of circle 2? Okay, so you got this S1 is different from that S1. S1 was what? Point satisfaction. But here you will compare equation of circle 1 with equation of circle 2. You will get your radical axis equation. Is that okay? There are also some property related to this radical axis. I'll go through one by one. Suppose that this is first circle, this is second circle. Okay, now look at this. So you know that this is common chord. Okay, so this common chord, if you want to find, you can find by using radical axis. So this common chord is equal to radical axis. Okay, so if you want to find equation of common chord, when two circles are intersecting each other, go with just circle 1 is equal to circle 2. You will get your situation done. Okay. Now also suppose that you have this circle and you have another baby circle. Okay. So suppose that this baby circle is touching your circle externally. So you want common tangent. Common tangent will be like this tangent I am talking about. There are, like, you know that there will be three common tangent. Okay. And I am talking about this. You know that direct common tangent, transverse common tangent. So I am talking about this tangent. Okay. So if you want to find out this, go with radical axis. Okay. Directly you will find out this common tangent. Okay. Suppose that same situation, if that circle is touching internally also now, and if you want to find out the equation of common tangent, go with radical axis. Okay. So this is also common tangent. Okay. And it is again radical axis as well. Is that okay? Now suppose that there are circles. Okay. And you have connected both centers. So if you will try to drop down radical axis now, this radical axis will be perpendicular to the straight line that joins the center of a circle. Okay. Also look at this. Suppose that this is circle 1, this is circle 2, and suppose that you have dropped down one common tangent. Suppose. Okay. Yes, it is not clear, but suppose it is correct. Okay. So now if you will drop down radical axis, this radical axis will bisect the common tangent, because you know that from this point this is length of tangent, and from this point this is length of tangent. This has to be same. Okay. So when we will not have radical axis, so if you will have a circle which are concentric, okay, then only you won't have that situation. Now, so now think about radical center. Okay. So what is radical center? So suppose that we have three circles. Okay. So its radical axis will be this one, and this radical axis will be this one, and this radical axis will be this one. So these means this radical axis is because of these two circles. This radical axis is because of these two circles, and this radical axis is because of these two circles. So if you will solve, the intersection point is named as radical center. Radical center. Okay. So how we will get? We will find out one radical axis and second radical axis, and we will solve. Then we will get radical center. I hope now you are comfortable.